Ladies and gentlemen, this is follow-up for the Solvent Solutes lab, the borax or salt water lab that we did Thursday. I don't know when we did it. But these are the follow-up notes that you missed because of shortened periods. We're going to start with the definitions again. The solute is what is dissolved into the solution. In our case, this was the salt. The solvent is what does the dissolving. And I still haven't figured out if dissolving is 1S or 2. I'm doing it with 1. You can do it with 2 if you want. And our solvent in this case was water. And we made solutions that reached a point of saturation. A saturated solution happens when no more solute dissolves. Now this is the kicker, at that temperature. Because the amount of solute changes as the temperature changes. We're going to get into the particle nature of that to figure out why that happens. Why did the amount of solute depends on temperature. Now let's do a little side note here to talk about what dissolving is not. So let's talk about melting. Melting is not dissolving. We did not melt our salt into our solution. We dissolved our salt. So melting is going from a liquid to a solid. And it might have looked like we were melting it because we started with a powder and we ended with stuff in water. We ended with a liquid. But melting only happens with heating. The only way to melt something is to increase its temperature. And while we were stirring in that solvent, at that point in time, we were not changing the temperature. We were dissolving it at a constant temperature. So with dissolving, there is no change of temperature. With dissolving, there's no change in temperature. Now don't confuse this with the fact that we did change the temperature throughout the lab. While we were stirring, we did not change the temperature. If you want to melt sugar, dissolve sugar, you put it in some water. If you want to melt sugar, you put it in a pan over low heat and you heat it until it melts. And soon after that, it's going to start to turn brown and caramelize. In Schoology, send me a personal message that says caramelized to know so that I know you are listening and not just writing. So back to this. So basically our lab came to this conclusion, that increasing the temperature of a solvent increases the kinetic energy and decreases the density allowing more solute to dissolve. We're going to illustrate this in the next page. Increasing the temperature of the solvent increases the kinetic energy, decreases the temperature, decreases the density, and allows more solute to dissolve. We're going to diagram what's happening on the particle level, because remember, 9th grade level understanding of this material is looking at the particles and what the particles are doing. So we're going to start with 2 containers, 2 beakers here, and make them the same size, because this is pretty much a before and an after diagram. We're going to make this one cold and this one hot. Now we're going to have the same mass of solvent. We did not change the mass of the water in this lab as we went from trial to trial. You might have seen a little bit of steam, but that was not anywhere near a significant loss of mass. So to show that we have the same mass, I'm going to put 20 dots of solvent into my beaker here. And since it's cold, my particles are moving slower and they're closer together. Now, they are taking the shape of the container. They are not crystal. They're not in a rigid pattern. And they are all about the same distance away from each other. Now I'm going to see how much solute I can get into those spaces. So I'm going to use pink here for my solute. And I'm going to fit them in the spaces. Okay, I got 18 to fit in the spaces between my solvent. Now let's move over to the hot water. Let's add some heat, bring it up to hot. I still have the same 20 solvent particles. I have not changed my mass. But now, since it's hotter, the kinetic energy is increasing. The particles are moving faster and farther away from each other. And since they're moving farther away from each other, their density has decreased. So let's put in our 20 particles farther away from each other. There's my 20 particles. You'll notice that the volume has increased. So my volume has increased. My density has decreased, and my mass has stayed the same. Now let's fall in love with density here. We've got density equals, I always draw it backwards when I'm doing this, mass over volume. My mass is staying the same. Volume's increased, density comes down. So let's see how many particles of solute I can fit in now. I need to maintain the same size and the same spacing. But since there's more space between my solvent particles, we'll see what happens. I got 31 in that time. So more went into the solution at a higher temperature because there's more space there for them to go into. So if I was going to graph this relationship like we did in the lab, my graph, my independent variable is temperature. My dependent variable is the mass of the solute. In the diagram that's shown by the number of particles, and I have a direct relationship. Now, unfortunately, you guys did not do the borax, which is more fun than the salt. And the borax crystals, borax solution, we let them cool overnight in pipe cleaners within the solution. And we get these beautiful crystals forming. Because if I go from cold to hot, and more solute goes into solution, if I go from hot to cold, that solute is getting squeezed out of solution and forms the crystals. See you on Monday. Have a good night.